Okay, so now we'll look at gravity. And just to start off with, gravity is the force of attraction between two objects, and it's dependent on the mass and also how far apart those objects are as well. Okay, so if you look at an apple and a building, because they're not very far apart and they're fairly tiny in comparison to like the whole world and the whole universe. They are very, very small. The gravitational force of attraction, it's as though it doesn't even exist because they're low masses relatively and they are quite close together. Same goes for like if you have planets that are really, really, really far away, then gravity doesn't really act on them. But if you have very large objects that are close by, such as the Earth or the Moon, then gravity is felt far more strongly and it has a big influence over the nearby objects. So we call this the field of influence around an object. It's gravitational field strength, and the strength of this field is called the gravitational field strength, which we represent by the letter G. And this is on Earth 9.8 newtons per kilogram. So the Earth and the Sun, the Earth and the Moon, there is there is influence. So there's a sphere of influence around the Earth, which gravity acts upon. And on the moon, the gravity is 1.6 newtons per kilogram. So it's a lot smaller than the Earth. So if an object comes into a gravitational field, it experiences a force of attraction. And in physics, it's this force that we refer to as an object's weight. And to calculate an object's weight, we take its mass and we multiply it by the gravitational field strength. So let's look at this example. So this man, he weighs 65 kilograms, and the gravitational field strength on Earth is 9.8. And so if we were to calculate the weight, that would be 637 newtons. So it's really, really important that we understand the difference between weight and mass. So normally we say that we weigh like 65 kilograms, but we should technically say that we our mass is 65 kilograms. But because the weight is the force acting on a gravitational field strength. So if we stood on the moon, we would have a different weight to, for example, standing on the Earth. Okay, now let's work out. So if we want to lift an object and overcome it, this is going to require work to be done. So if we're lifting an object up, energy is transferred to the gravitational potential energy store. And this is the energy that is required to raise an object at a height. So it's moving against the gravitational field strength. So we write it as EP is equal to mgh, where m is the mass, g is the gravitational field strength, and h is the height. Sorry, it's going the wrong way now. Yeah, so h is the height. And the units for this, so mass is in kilogram, gravitational field strength is Newton per kilogram, and the height is in meters. And that's also measured in joules. So here we have an apple. It's been raised by 3 meters. The apple weighs 100 grams. What's the gravitational potential energy store? So the way we work this out is we look at, okay, the formula is EP equals mgh. Its weight is, sorry, that should say 0.1 because it's 100 grams. But imagine the weight of the apple is 200 grams now. So 0.2 times 9.8 times 6, which is 11.6. And here we've also made sure to convert. So here we've converted 200 grams to kilograms. So done 0.2 times 9.8 times 6. So just to summarize, gravity is the force of attraction between objects. Mass is separate, um, and it's dependent on how far an object is, as well as the mass. And gravitational potential energy is equal to mass times gravity times height. And then weight is mass times gravitational field strength. So this is just really, really important to understand about GPE, gravity, and weight. Now we have quite a difficult question here. So we're going to read through it, and I would like you guys to pause and try. We're going to combine what we've learned for kinetic energy and also gravitational potential energy as well. So here you've got a student before and after a bungee jump. The bungee cord has a length, unstretched length of 30 meters. The mass of the student 60 kilograms and the gravitational field strength is 9.8 newtons per kilogram. So we need to here do three different things. First of all, we need to calculate the change in gravitational potential energy of the student at 30 meters. Then we want to get the maximum change in the gravitational potential energy of the student. And then we want to find the speed of the student after falling 30 meters if 90% of the energy in the student's gravitational potential store is transferred to the student's kinetic store. So firstly, let's just focus on the first part of the question. So we just want to find the change in the gravitational potential energy of the student. Now, the way we can do that, so I will be using my annotate here, is we're just going to use EP, so gravitational potential energy equals mgh. So we've done this formula and now we're going to use it. We know that the mass is 60 kilograms. We know that on Earth it's 9.8 and we're also given that, so that's gravitational field strength. And we know that the height is 30. So straight away, we are going to get that the gravitational potential energy is 17,640 joules. And if you want, you can put that into kilojoules, so 17.64 kilojoules. But I'm not going to do that. Okay, so that is how you would get the following answer. See if you got that. Okay, so now let's move on to part B. We want to find the maximum change in the gravitational potential energy of the student. So the maximum change in the gravitational potential energy of the student. Now the maximum change, we're just going to change the distance. So the maximum is when it's going to be 75. So for part B, it's quite simple, but we're going to do the same thing. We're going to do 60 times by 9.8 and then just times it by 75 for the distance. So that's going to be 44,100 joules. Now, for part C, this is really quite a difficult example. But the speed of the student after falling 30 meters, if 90% of the energy in the student's gravitational potential store is transferred to the student's kinetic store, we're going to have to use both of our formulas. We're going to use kinetic energy and gravitational potential energy. And we're given this 90% here as well. So we were told that 90% of the potential energy is changed into kinetic energy or transferred into kinetic energy. So first of all, we want to find 90% of our gravitational potential energy, which was 17,640, not the maximum, just at 30 meters. So at 30 meters, 90% of 17,640. So that's just doing 0.9 times by 17,640. And that gives us 15,876. So now that is how much of our gravitational potential energy is transferred as kinetic energy. Now we want to find the speed. So we're going to make a half mv squared equal to this 15,876. And then we're going to put in our mass as 60 and rearrange the formula. So we're going to do 2 times 15,876, divide that by the mass, and then that gives us v squared. And then we're going to root it to actually find out what our v is. So we're going to root that, and that is going to give us 23 meters per second. And so that's our final answer. Now we're going to learn about elastic energy in our next video, and then we're going to add another part to this same question where we're going to involve the elastic potential store as well. So I hope you enjoyed that session. If you have any questions, comment below, or and then please also try the extra questions on this topic. See you guys, bye.